this video, we're going to walk through how to find graph features of a quadratic function given a picture of its graph. So by the end of this video, you should have a good handle on how to find all of the graph features listed here. We're going to go through the vertex, domain, range, axis of symmetry, x-intercept, y-intercept, and whether or not it's positive or negative. I'm going to start all the way down at the bottom, positive or negative, because that's going to help me with a few other things as well. Now, if I do this example, and I'm looking at the graph that it's giving me, the parabola of a quadratic function, I'm going to notice one thing right away, that these endpoints of the parabola are going down. Because they're going down, that means my function is negative. All right, that's the first graph feature. And that will tell me then that the vertex is a maximum. All right, down, and it comes all the way to the max point right there. Now, that's just two very key pieces of information to help you with this process. And now, I'm going to start with the vertex after that. I've already discovered that it is a maximum point, and now if I want to plot that point, I need to come up with the x and y value at it. In this case, it doesn't move left or right, so the x value is going to be 0, and then if you notice, it's shifted up to the y value of 4. So my vertex is 0, 4. The domain in this case, we've mentioned that domain is the left to right motion. In this case, it always starts at negative infinity, and it always ends at positive infinity. And the idea is, if you can put your pencil on the leftmost part of the graph right here, and draw it continuously, or draw it, and if it is continuous, meaning you don't have to pick up your pencil and it goes on in both directions forever, then it's determined that it's from negative infinity to positive infinity, right? Meaning that all of the x values in this function exist. You go from negative infinity to positive infinity. Another way you can write that, this means the same thing, but you can put this symbol, which means all real numbers. That's the domain. And hint, the domain for a quadratic function will always be all real numbers because it's a parabola and they go on in both directions forever. Now, the range is a little bit trickier, and I want you to take a look at both of these parabolas we're working with in this video. The one I'm doing, it goes down, so keep in mind with that, but the one I'm going to have you try to do, hopefully you notice that it is flipped and it's going up. So because mine is going down, I have to think when I'm dealing with range, it is the floor or it's the lowest y value to the highest y value. Okay, in the lowest y value, it's easy to say that the lowest y value would be that at 1, 2, 3, 4, 5, -5, but you have to remember that these arrows mean that this graph goes on forever. The endpoints are going on forever, and so it's going forever in the down direction, which means that the range of this, the lowest y value, is negative infinity. Okay? Now, we go to the highest y value. In this case, then, the highest y value is right there. And if you notice, that is the y value of the vertex at 4. So this graph is contained between negative infinity, these endpoints, and positive 4. Now we have to put a bracket around 4. Oops, I've moved that. There we go. We have to put a bracket around 4 because the graph is a closed dot, or the graph goes through the point of 4. And we have to write it like this, negative infinity to 4, because again, it's the lowest y value to the highest y value. All right, moving on to the axis of symmetry. The axis of symmetry is an equation that cuts the graph in half. And if you notice here, is where the graph is cut in half. And so the equation is always going to be x equals something, because x equals a number will make a vertical line, and a vertical line is what's necessary to cut this graph in half. So in this case, x equals 0. And for the axis of symmetry, the equation will always be x equals whatever the x value is of the vertex. All right, moving on. X-intercepts. Intercepts means where does it cross a certain axis. In this case, we're looking for where does it cross the x-axis. In this case, there's 2 points, one right here and one right here. So I want to write the coordinate point of that, and we'll get into what's the coordinate point because we're just looking at the graph and where it hits. And so I'm going to put one x-intercept is at -2, 0. The other x-intercept is at 2, 0. All right? And if you notice, there are 2, so you have to list 2 different points. And then finally, the y-intercept. Now in this case, it does intercept the y-axis, and if you notice, it intercepts at the same place as the vertex. That won't always be the case, but in this situation, that is how it works. So the y-intercept is at 0, 4. And I'm done. I have found all the graph features that are necessary to describe this parabola. Keep in mind the range, especially as you try yours on your own. So please pause the video and go ahead and try yours on your own to check your understanding. Here are the answers that hopefully you have gotten if you were to list out the graph features of the parabola you've looked at. To begin, again, notice that the endpoints of this one are flipped as compared to the one that I did. So this one is going up, which means that it's positive, okay? That means that the vertex, I didn't list this, but it's important to know that in this case, then, its vertex is a minimum, meaning that it forms a valley, not a mountaintop in the first example. Then going on, the domain is always all real numbers for a parabola, but please take note of the range. This is why it's tricky. If you notice, the infinity is flipped from starting with -infinity here and then ending with +infinity here. And the reason for that, again, it's the lowest y value to the highest y value. In this case, because it's positive and it's going up, the y value of the vertex here is going to be the lowest y value, all right? Because it's ending going up forever instead of starting going down forever. So that's why you start with the y value of the vertex and you end with +infinity, all right? Moving on, the axis of symmetry is x equals 1. Again, the vertical line that cuts it in half. X-intercepts are at 0, 0, right here, and 2, 0, and the y-intercept is also, in this case, at 0, 0. Thank you so much for watching.